So welcome everybody to Software Quality Management, a proactive approach. My name is Robin Goldsmith, and I'm going to be your speaker today. And we are recording this session. And so this session, this webinar, and others like it are all in relation to the upcoming Software Quality and Test Management Conference that will be held this year in Washington, D.C. from May 31st through June 5th. And this is a conference that is focusing on quality and test management. There's lots there, though, for practitioners, whether or not they're in a management role, but there is an emphasis as well upon management topics. I will be presenting several seminars and a talk, and as will a number of other colleagues in the quality and testing community, and we hope that you will find that this is something that you would like to attend, and if you register by March 31st, you get a discount of up to $500. So enough of the sales talk. Here's a little bit different sales talk. Who am I? I do work with and train testers and other quality professionals, along with those in who deal with requirements and business analysis, and project managers, people with metrics, return on investment, and anything else that you'd like. Once upon a time, I held real jobs, including some very technical ones, and then I moved into areas that dealt more with methodology and management. I was a member of 2 working groups that developed IEEE standards. IEEE Standard 829, that the revision that came out in 2008 for software test documentation, and Standard 730 that came out last year, and it deals with software quality assurance, and we'll be referencing it in this talk and in related talks. I'm a subject expert for the International Institute for Business Analysis for their BABOK, Business Analysis Body of Knowledge Volume 2, Version 2. And I'm also a subject expert in requirements and testing for TechTarget.com. Okay. And I have a book called Discovering Real Business Requirements for Software Project Success. And enough about me. This webinar today is a preview of a full-day seminar, like titled Full Day Seminar, that will be held on Monday, June 1st at the SQTM conference. And you can go find out more about that and hopefully register, and hope to see you in it. So let's get into today's webinar. And got a couple of objectives here. I'd like you to be able to distinguish system from software quality, and the terms quality control, quality assurance, and quality management. Make some meaningful distinctions there. I'm going to describe to you the 6 functions of what I call proactive software quality assurance, and share with you what I feel are the 5 elements of proactive software quality management, and then relate them to the proactive software quality assurance. Hopefully you'll find this understandable and relevant and informative and valuable. So I'm not going to do all the work. I'm going to ask you folks to contribute. And so says chat, but there's actually a tab called questions, which apparently a lot of people tend to use anyhow, rather than the chat tab. So what I would really like you to do is to chat what you mean by system quality and what you mean by software quality. And as you're doing that, I want you to think about what difference it makes how you define these two terms. Does it matter? And what kind of issues there are with your organization with how they either do or do not define these terms. So it's going to be a long and slow day if you don't share with me on the question tab your definitions of system quality versus software quality. So I'm going to, very good. So let me see here. So let's see now. Darren says the ability of the environment to support the applications running on it. Okay, so I'm going to type this in here. Let's see, where did I? So I will tell you that my computer sometimes makes mistakes when I type things in it. Let's see. Let's see. Let me go back and see if I can capture that accurately. The ability of the environment to support the applications running on it. Okay. It's a good answer. The ability of the environment to support the apps running on it. Oops. Sorry about this. The app's running on it. Okay. So hopefully that's given additional people a chance to add definitions. Okay. Software quality, the ability of the application to perform the required functions. Okay. So the ability of the application to perform required functions. Okay, good. Let me see if anybody has offered any additional definitions. Software quality is how well the software meets the design requirements and functionality. Okay, good. So, how well the software meets design requirements and functionality. Okay. Desired by the customer. And system quality is the performance level. Let's see. Functionality desired by the customer. And system quality is the performance level of, let's see, pardon me for a second. It's the performance level of the system created for a customer. Where is this? It's the performance level of the system created for customer. Okay. And bear with me here as I look further. Okay. And looks like we've got one other one here. Can the system handle large loads? Is it secure? Large loads, is it secure? Is it available when customers need it? Is it available when customers need it? Okay. Well, good. Well, I thank you for your contributions. And this looks like all that we've got, and I appreciate that. So we've got, you know, some distinctions here. And I'm not sure whether these distinctions are ones that everybody would identify with. There seems to be some similarity in those that were offered. Guess I need to check my typing here. Okay. Let me share with you what the common distinction is. That system quality includes hardware and software. How did I pick up that extra letter there? Okay. And software quality is just software. Now, does it matter how we define these things? Does it really matter? Does it make a difference? And are there issues that your organization might have related to how they do or do not define these two and make any distinctions? Okay. So if you have any thoughts on that, please feel free to put them into the questions box. But as we're talking, I'm going to continue on. So this system versus software quality difference, how is it relevant to quality control, quality assurance, and quality management? Well, one of the things that happens is that this distinction between whether hardware is or is not included is really a design decision. It's not a requirements decision. It's a design decision. And if we initially make a determination about presumed design, okay, and that determination turns out to be wrong, okay, there's a pretty good chance that it will have some kind of an impact, probably not a positive impact, on the requirements. Okay? So when people prematurely decide what their answer is, they tend not to be very good at identifying what the question is. And then if that determination subsequently changes, like you move from a hardware and software to an all-software solution, which is increasingly happening these days, it's just further messing up the construction and the design and the requirements. And so quality, ability to provide quality, can really get messed up when we confuse and think that this hardware versus software distinction is inherent rather than a response to presumed requirements. Okay. And so I'm going to suggest that people spend far too much energy on this somewhat artificial, arbitrary distinction between system quality and software quality. I use the terms interchangeably, and increasingly you just can't assume that a system will or will not have hardware components. Now, quality is the key to delivering quicker and cheaper. And the reason that I say that ties back to some concepts that were made popular by Philip Crosby. Some of you may know Philip Crosby. He wrote several books. He was one of the big three gurus of the total quality management movement. And probably his best-known book is titled Quality is Free. Now, he didn't really mean that quality was free, but he had a very special meaning of what's called the cost of quality. And that is that as far as Crosby was concerned, quality had to be there. The necessary quality had to be there. And so that was kind of the minimal cost. You couldn't avoid that, achieving the necessary quality. But that all of the additional costs attributable to poor quality, those were the things that tended to cause the difficulties. And Crosby said that those costs, those additional costs, included the costs of assessment or appraisal. And that's a lot of what quality and testing professionals do. Costs of prevention, and hopefully we're doing some prevention. And the costs of failure. What happens when the quality is not adequate? And that failure can be internal failure. That's the type of failure that most of us probably focus on the most, you know, fixing programs and restoring data and things like that. And then there's the costs of the external costs of failure. Those are the costs, for instance, to your clients, to your customers. You know, what happens if this thing doesn't work? So, for instance, in the news these days, we're seeing that General Motors, in this instance, is getting hammered because they had a problem with their ignition switch on the car turning off while the car was in motion, and people were injured and died from that. Those are external costs, which ultimately General Motors undoubtedly is going to end up having to pay, which may well exceed the costs of fixing the ignitions. So let's look at some common definitions of quality. And the we had a comment, by the way, that should hardware be part of requirements? And my answer is that hardware is a solution. It's a design solution. So we've got these common definitions of quality, and I want to look at each one with regard to whether there are any issues with that definition and what difference does it make. So many people say quality is customer satisfaction. Now, I agree that customers generally are, or at least we would expect them to be satisfied by quality, by higher quality, that higher quality should satisfy them or satisfy them more. But the fact is that satisfaction is at best a response to quality. It is not the quality itself. Meeting or exceeding customer expectations. Okay? Now, indeed, customer expectations are very important with regard to quality. But there's a problem that with this definition, because a customer could expect lousy stuff, and you could give them a lousy, poor quality product that would meet or exceed their expectation that they're going to have a lousy thing. Okay? That is not quality. Okay? And similarly, a customer could have expectations which frankly are excessive, and you couldn't meet them no matter what, okay? Or let alone exceed them. Okay? So there are some difficulties with this meets or exceeds customer expectations, and of course you can have multiple customers with multiple different expectations. Some people say that quality is optimization or value. Well, optimization is optimization. Optimization relates to the production, hopefully, of quality, the production of value, but value and quality are not the same thing. They are related, but I don't think they are the same thing. I think people can get value from things that are not high quality, that are not optimized, and there are some things that are optimized but aren't high quality, things that are high quality that may not provide value as much as you'd like, and so forth. Phil Crosby's definition is perhaps the most widely used. Crosby says that quality is conformance to requirements. Once again, there's a lot of truth in this, but it misses the issue of the quality of the requirements. Conformance to incorrect requirements is not quality. Conformance to inadequate requirements probably will not produce quality. So there's a relationship, but the requirements themselves have to be quality, and that's not part of Crosby's definition. Now, some people tell me that he must have intended that, but you know, I think if he intended it, he probably would have said it. There are a number of statistical definitions of quality. W. Edwards Deming, another one of the total quality management gurus, tended to speak in terms of statistical measures. Now, the issue is lack of defects. Well, yes, if something has defects, that's probably going to diminish its quality. But we have the same type of issue. Is the specification that you are comparing to determine whether or not there are defects, is that specification accurate and adequate? Okay, that's got to be another part of it, and relevant, because you can have all kinds of conformance and still not have something that people would necessarily walk across the street for. Okay. Related to that is Six Sigma's minimal variation within specification. And so Six Sigma focuses on variation. Well, variation is an element of quality, but variation is about the mean, about the average performance possibly in a variety of ways. And if that average performance is inadequate, small variation around an inadequate, inappropriate performance is still not quality. And once again, we've got the issue of whether the specification is right. Joseph Juran, the third of the big total quality management gurus, said fitness for use. And this is in many ways probably the most flexible, probably the easiest for people to buy into, but it still gets to the question of what use are you talking about. So if the uses are not defined adequately or defined appropriately, fitness for improperly defined use is not quality. Okay. So we've got all these common definitions, and people use different definitions for the same thing, and each of those common definitions has some big issue with it. And what happens when everybody uses terms in different ways and has different ideas behind them? Okay? Well, then what happens is that everybody gets disappointed because the other guy isn't playing by the same rules, isn't playing the same game. And it's hard for people to know what to do, and it's hard for people to tell whether what they've done is suitable quality, and everybody points fingers at the other party saying they don't care about quality. Quality is this, they don't care about it. They say, no, quality is that, and you don't care about it. And this giant finger pointing. Okay. So, hopefully this is understandable. I've got another comment here. Let me see if I can read it. Okay. So, so requirements are our biggest issue. Okay. We have poor quality in our requirements. Okay. Well, that's a pretty common experience, folks. So if we don't have common definitions, we can't manage them. Now, I'm going to possibly introduce you to 3 quality dimensions. Now, this concept of quality dimensions is not something that I invented. These are concepts that have been around at least 100 years in the quality control world, long before software. But people have been doing things to control quality for a long time, and we in the software world hopefully can learn from them. So there are 3 quality dimensions. The first is quality of design. That's what's it need to do. Okay? And that relates to the needs of the stakeholders. Now, quality of design kind of includes both requirements and design. That is, that the design is suitable to meet the requirements and the requirements are right. costs and benefits and schedules are accurate, and that there are trade-offs, undoubtedly, or when there are trade-offs, they're based on adequate information. The second quality dimension is quality of conformance. This is how it's produced. This is what most testing and quality assurance people tend to do. You're primarily testing that things conform to the design, that appropriate standards and conventions have been applied, that people have worked appropriately with using suitable methods and tools. Now, in addition, management actions and practices are also part of quality of conformance, although most of the time the QA and testing folks I know don't address management practices. And even though we tend not to be conscious of it, on time and in budget are parts of quality of conformance. Because if the product arrives late, its quality is diminished because it's not available. If that product costs more than somebody wanted to pay for it, possibly more than the value of it, then that quality is diminished as well. So that's quality of conformance. And then the third dimension is quality of performance. And this is how things are delivered. Availability, it actually works, handles the workload, and the big part of it is that it is supported and maintained responsively. Now, a lot of software quality assurance and testing stops at the point of delivery. And this is saying, no, you've got to pay attention to that product in operation as well as development. Okay, so that's a little bit broader view. And then there are these things called quality factors. Some of you may be familiar with them under the name non-functional requirements. I will encourage you, or rather discourage you, from using the term non-functional requirements because it's misleading. So quality factors, some people think that quality is only attributable to these quality factors that are sometimes called ilities, because a lot of them end in ility, like usability and reliability and durability and maintainability and so forth. But in fact, the bulk, the biggest component of quality is not the ilities, okay, but the business functionality that in fact the product enables us to do. So people say quality requirements and they're only thinking of the ilities. I think that you're well advised not to use the term quality requirements. I think it's misleading. So some of these are internal or interior, some things that are of primary interest from the engineering perspective. Some of these are exterior, primarily of interest to the user. And then some of these relate to the future, adaptability, maintainability. These are future types of characteristics. So when we take all of this information and put it together, what we see is that quality really deals with two things, how well and how much. And that they interact, and you can't separate them or you can't deal with them individually because they do interact. So how well is defined in engineering standards. Engineering standards define how to do something well. And they relate to quality of design, quality of conformance, and quality of performance. The business requirements, the how much, the business deliverable capabilities. Okay. Well, quality of design tends to be the topic during the analysis and design activities of a project. This is true whether you're in an agile or a more structured, more traditional role model of development. Quality of conformance is primarily being addressed during the development and testing. And quality of performance is primarily being addressed during operations. Okay. But note that we need to have requirements that deal with each of these, not just one. So when we put all of these ideas together, I'm going to suggest a definition of system quality, system or software or product quality. I use those terms interchangeably, where the quality is the extent to which the product, system, or software meets weighted, which means you're prioritizing, both stated and implied, interior, exterior, and future real business requirements, business deliverables that provide value when delivered, of all internal and external stakeholders. Stakeholders are the source of requirements, and that's consistent with standards of design, workmanship, and performance. Okay. Now, I summarize that as meets real business requirements consistent with standards. So I use meets real business requirements consistent with standards as a shorthand version of this somewhat longer and more cumbersome definition. And I think that this addresses the ideas in those well-known definitions that people make for quality, but also brings in that the requirements have to be the right requirements. The real requirements are the right requirements, the ones that you end up with after you possibly have started wrong and then had creep and modifications and adjustments and fixes and everything else. And that those requirements need to be consistent with relevant standards. Okay. Now, hopefully this is understandable, and hopefully you see the value in having a definition like this. Okay. Now, the way that this works is that the more of the relevant requirements which are met, the higher the quality. And the more demanding the standards are with respect to meeting those requirements, the higher the quality. So we've got the how much and how well. Both of those factors play in. Now, a lot of people think that quality is in the eye of the beholder. And it's true that quality needs to be from the perspective of the customer or the user. But I'm going to suggest that quality is absolute, that quality is an engineering concept. It is not a subjective variable. What varies is the amount of quality that you receive. And that's going to be governed by available resources, money, priorities, staff, skills, and other considerations. So the quality is absolute. What varies is how much of it you get. And value is the perceived benefit of the quality received relative to the costs of producing and receiving it. So I'll ask your consideration of these definitions. Hopefully they're understandable, and hopefully you find them valuable and useful. I certainly do. So now we've got three other terms: quality control, quality assurance, quality management. And many of you may not really make big distinctions between or among these three terms. A lot of people use the term quality assurance when they're really talking about quality control, but some people have separate meanings. So if you have any particular distinctions that you make between system or software quality control versus system or software quality assurance, okay, or system or software quality management, if you use those terms, please enter them in the question box, and we'll try and compare notes there. Okay. My experience is that most organizations don't really pay much attention to the term quality management. Some organizations do, though, and that may mean something different from quality assurance or quality control. So I'm tap dancing here for a minute. You know, in my experience, we are mainly familiar with these terms because groups or roles are called one or the other. And that means that in a given organization, the meaning for these may be defined from an organizational or role standpoint. Well, let me continue on here because I haven't seen anything. So quality control. Testing is the most evident form of quality control. So when we use the term quality control, you can almost use that synonymously with testing. And let's see now, we did get an answer here. Okay. So we said quality control is the activities an organization has in place to ensure quality in products. Quality assurance ensures quality in the activities used. Okay, good distinction. Very much in line with what I use and what I think is generally accepted as the proper distinction. So the part of the confusion is that a lot of organizations have groups and roles called quality assurance who just do testing. Now I'm not trying to demean testing, only to say that testing is quality control, and if your title is quality assurance but you do quality control, then that distinction between quality assurance and quality control is probably not being made. Okay, and you're probably going to miss out on things. Okay, and let's see, somebody just said quality control is product-oriented and quality assurance is process-oriented. Okay, and I agree completely. Okay, so thank you for that. Let's see, who was that? Darlene, thank you, and Alan. Okay, Great. So you're right on target there. Those are the classic distinctions. Okay. Now, when organizations have separate groups, that is a group called quality control and a group called quality assurance, okay, then that can be a strength, or it can turn into internal bickering and duplication and things falling through the cracks and so forth. It doesn't have to, but that's always a risk when you have confusion or seemingly similar roles. Okay. So there's an IEEE standard, 12207, which is kind of the overarching standard for systems and software engineering, life cycle practices. And that standard, 12207, does indeed make some distinctions among these three terms. So there are, in the standard, what are called organizational project enabling processes. Okay. And one of those is quality management. Now, notice the definition of quality management. The purpose of the quality management process is to assure that the products, services, and implementation of life cycle processes in the organization achieve quality objectives and customer satisfaction. Okay? Now, contrast that with software-specific processes, okay, which include testing or quality control. That's to confirm that the integrated software product meets its defined requirements. So there's definitely a mention of emphasis on the product. And then software support processes, which includes the software quality assurance process. And the definition that IEEE Standard 12207 gives is to provide assurance that work products and processes comply with predefined provisions and plans. So certainly the quality control or testing mentions products, and the quality assurance process refers to processes and work products as opposed to end products, okay, and that they comply with predefined provisions and plans. Now you'll notice that there are these other software support processes, and one of the things that I notice is that very often one or more of these are coupled with software quality assurance. So software quality assurance might be considered part of a configuration management group, or configuration management might be considered part of a software quality assurance group, or audits and reviews and so forth. Okay. So there tends to be a fair amount of overlap like that. So testing examines end products, typically in terms of conformance to specifications. And unfortunately, too often, people refer to specifications, which are a type of design. They call them the requirements. So very often when people say, we're testing against the requirements, what they're actually testing against is the design, the specifications. Okay. So quality control testing looks at products, okay, and primarily with dynamic execution of the code. Quality assurance should be assuring or confirming that the processes producing the end products are producing quality products. Now, in some organizations, when they say quality assurance, what they're really referring to is examining intermediate products within the development process. In other words, typically reviews of requirements and designs, or compliance of documents to various standards and guidelines. And typically that's looking only at the format, not the content. And this is where QA groups often get equated to being a traffic cop, and it can become a major source of resistance, and you know exactly what I'm talking about. What I want you to realize is that examining intermediate products and examining compliance to formats and procedural standards are all quality controls. Those are not quality assurance. Those are quality controls as well. And when we came up with the major revision of IEEE Standard 730 for software quality assurance, one thing that we did state quite explicitly is that reviews of requirements and designs and compliance with procedures and formats and so forth are indeed quality control, not quality assurance. So let's look at where quality comes from. First of all, it comes from the definition of quality. So the better that system quality is defined, the more adequately system quality is defined, the more effective or the more successful you're going to be in achieving it. And then it comes from how well the developers implement things to satisfy or achieve that definition of system quality. And then it comes from how well testers detect the defects that do exist, because humans tend to make mistakes. Now notice, the impact is highest at the top, but the effort is greatest at the bottom. So we spend a lot of time catching defects and still end up having products that aren't right because their quality wasn't defined appropriately, and we're referring back to their requirements, their real business requirements. So when we get proactive, and a number of these concepts are included or a basis for a lot of the thinking in the new revision of IEEE Standard 730 that came out last year. We know that we need to deal with processes, so that we need to have appropriate methods and techniques. Okay. So it's not just conformance to predefined plans and provisions, but that those plans and provisions need to be appropriate, okay? And that they need to be used, they need to be applied, that the environment in fact promotes quality. We also need to make sure that projects indeed act in accordance with these processes, so that all of the development deliverables, the intermediate as well as the end deliverables, in fact, are serving the appropriate methods and techniques, that we're getting the requirements right, that we've got responsive designs, we're using suitable methods and tools, and so forth, so that we're doing things that are appropriate for producing needed quality. Okay. So that's pertaining to how well the quality is defined and how well it is implemented, and ultimately how that implementation includes the testing. And then the proof of the pudding is in the product. So testing the delivered software to make sure that it works properly and does what it needs to do is the tail of the dog that's going to turn out well when the quality is defined appropriately and the developers implement it appropriately. And that we see that the value, the greatest value, is at the process level, then the project level, then the product level. Historically, the effort and attention has turned this on its head. And many organizations, all they're looking at is products and project management budget and schedule, but not necessarily the adequacy of the project to produce the necessary product. And so we end up catching lots of defects, but still missing many of them because we haven't got the processes working properly to create and manage and continue appropriate projects to produce necessary products. So proactive software quality assurance, which we talk about much more in the seminar, establishes an environment that promotes quality. It goes from conception through retirement, cradle to grave. It defines when and what and how to test, and test or address, making sure that appropriate design, workmanship, and management practices are identified and used well. And we're always attending to ways to improve and prevent errors rather than just catching them. But all of this is enforced, if you will, by various quality controls, including testing. But there can be other quality controls, such as project controls, configuration controls, and so forth, that taken together give us the means for telling how these other things are doing. They're the way that we get the measures of how things are turning out. And so proactive software quality assurance has 6 functions. First of all is defining what are called quality assurance plans. That's what we have to do in order to produce quality. Historically, quality assurance plans were only what we did to check compliance or conformance to pre-existing plans and procedures. But quality assurance plans include identifying what needs to be done, the various methods and practices and standards that taken together constitute doing it well. Now, let me emphasize, the role of the QA professional and the QA group is to make sure that these things get done, not necessarily to be the individuals who do them, but to make sure they're done by people with necessary requisite skills and knowledge. Okay? And then to make sure that it does get done right with systematic quality controls of both processes and products. And that based upon those, we're going to get data, keep track of relevant quality records so that we can analyze and report and learn from our experiences. And the final function of a proactive software quality assurance function is to direct attention to improving quality, to encouraging quality practices. Now, a lot of quality organizations really overdo the cheerleading number 6, but they fall down on the others, and then that actually works against them because they don't have the substance that they're cheering about. You need to have all 6 of these. And managing software quality means identifying how to create quality, assuring that the methods and processes indeed will create quality and have been used effectively, assuring that the result of these processes is indeed suitable software with suitable quality, and that includes both creating it and supporting it, and that as we go forward we learn so we can improve our methods and processes both for creating as well as evaluating the quality of our software products, and balancing costs and time. Quality is free. The cost of quality is poor quality, but let's balance our efforts so that they pay off, so they have a net benefit. And so I'm going to suggest that proactive software quality assurance and proactive software quality management are very often and very much the same thing. The proactive software quality assurance embraces and incorporates what software quality management does. And especially, and this is another thing that we put into this revision of IEEE Standard 730, is that if there's not some separate organizational function responsible for what is called quality management, quality assurance needs to make sure that it gets done and done well. So the title on the door, if it's there, you can split the work, but if it's not there, whoever is there, regardless of their title, has to make sure that the full story is addressed, regardless of whether it's involving hardware or software or both. So if you've got people called quality management, they've got to make sure that the quality assurance stuff gets done if it's not being done by somebody else. So hopefully we have indeed distinguished system from software quality, made some distinctions between quality control, which is products, and quality assurance, which is processes. And I would contend that quality management is really embraced by proactive software quality assurance, that it's two sides of the same coin. The proactive software quality assurance has 6 functions devoted to making sure that the right stuff is done well. And that quality management, proactive software quality management, it involves essentially the same things looked at from a slightly different perspective. So I want to thank you for your participation. I hope that you found this helpful. I hope you will want to find out more about it and attend the SQTM conference, and especially attend the full-day seminars that I'll be presenting on proactive software quality management. And that, by the way, earns credit toward various IIST certifications, including the CSQM certification, where that course satisfies the body of knowledge area 1. So if you have questions, please put them in the question box or comments, and we'll stay on the line a little bit in case there are any other questions. Anything anybody would like to raise? Okay, so let's see here now. Thank you. This was very informative. Okay, good. Hope that you're able to use it. Okay. Any other questions or comments? Anything? If I can be of more assistance, my email address is robin_goldsmith@iist.org. And I'm not sure, since we are recording this, I'm not sure exactly when the recordings will be how and when the recordings will be made available, but that will be something presumably that will be happening in the not too distant future. So just to make you aware, in case you're not aware, IIST, in addition to presenting the SQTM conference, also presents weeks of training in various spots throughout the country. I believe Minneapolis is coming up in another month or so, and there will be subsequent weeks of training. Each day of training has, I don't know, 5 or 6 different courses, and they each course earns credit toward one or more of the IIST certifications. In addition, we can come to you, and we also have many of our seminars, our full-day seminars, are available in recorded format, and you can find out about that at www.iist.org. So, if there are no more questions or comments, I'm going to thank you and wish you a good day, a good afternoon, a good morning, and I hope to see you and your colleagues at the SQTM conference, future webinars, and other IIST events. So, thank you very much.